Good evening, everyone, and thank you all for joining us today. My name is Rashmita, and I am the event planner for Microsoft Reactor India. This session will run over the next 60 minutes, including Q&A. But before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section will be open throughout, and we do encourage you all to participate. So please feel free to drop all your questions in the chat section. I would now like to welcome Dr. Ravi, our speaker for today's session. Dr. Ravi is Director of AI and Emerging Technologies at Compunnel and Forbes Technology Council member. But for now, I will hand over to him to begin the session. Let me bring Dr. Ravi into the stream. Hi, good evening.
Hi, very good evening, one and all.
Thank you. Thank you so much for your time and thank you all. Thank you for joining us. So without any further delay, I will hand over the floor to you. Let me bring your screen up. There you go. I'll be at the backstage. Let me know if you need anything. Thank you.
Rashmika, thank you so much. So once again, a very good evening, good morning, everybody. And the agenda which we have brought forward for you to learn, to understand, to contribute, and take into the real consciousness is that how exactly now we can make a better world, leveraging generative physical AI for social impact. With that, I would like to welcome everybody from the leaders categories, from developer forums, from the community side, and everybody who is basically now going to leverage generative physical AI for the futuristic aspects of AI. So, thanks for joining once again, and let me just begin the presentation. And as I mentioned, that the major aspect which I have been covering, since long time back, like in before 20 years, it was more on fintech. It was more on the revolutions on happening on the machine learning AI side, and then finally we are at the era where exactly generative AI has played a vital role. So you can see that these days I'm working majorly on Gen AI based physical AI kind of disruptions, and that basically is the ideology that we are bringing here. So talking about the kind of major credentials, so I'm also, as Rashmika already mentioned, that I'm a Forbes Technology Council member where I'm a group leader for ethics and governance. So we'll be inclined to discuss those aspects also from the ethics and governance part, that how exactly we can leverage the best in class governance frameworks within Azure ecosystem micro and the marketplaces which are available, joining hands in hand together with respect to the major platforms, including Nvidia to the other major players in the market for generative physical AI. So a very brief overview, like we had been working with a number of major clients where we were partnering them with respect to the automation anywhere kind of framework, or let's say if I talk about Snowflake, the other database platform players with respect to the other cloud agencies. If you talk about, so major accreditations are coming from Microsoft as well. So we are actually digital app innovation partner. We are data and AI partner at Microsoft Azure. And if I talk about major clienteles, we had been serving throughout the years, more than 30 years, right? The major companies which exactly work from fintech to industry to let's say manufacturing, and even the farming sectors as well. We have been working a lot. So if I talk about current scenario, it's majorly, if you have been seeing, that kind of evolution has happened more on generative AI side these days, right? What we are bringing in is how we can leverage generative AI based digital twin capabilities into the physical world. So it means that digital twin is going to be something intermediary or middle layer, which exactly works between generative AI and let's say the physical AI. So that's the kind of a intermediary, or let's say transition phase, which everybody should work upon. So right now, if you talk about smart manufacturing aspects, if you talk about smart farming, if you talk about smart city management, all these things you need to work around to get into the next level of AI revolution, that would be on generative physical AI. So if you globally go ahead and you on an incognito mode also, if you write there that it's generative physical AI, you'll find that certain publications are there from my side on Forbes as well and the other platforms, and you will see that majorly I'm talking about what exactly this particular technology could be leveraged, how exactly it can be leveraged, and why it should be leveraged for next level of revolutions. Next level of revolutions, if it comes to industry, it is industry 5.2. But in my sense, in my opinion, it should be actually agriculture revolution, or let's say sustainability revolution powered by technology revolutions. So that basically is the major agenda, and we'll be covering up almost these kind of scenarios, that how we go ahead for modern day predictive maintenance analysis, how we can have the environmental impact assessment, with leveraging these techniques and technologies, and how we are going to work out on major ecosystems, which includes 3D modeling, 3D visualizations, mixed realities, bypass platforms, SCADA systems, and all. And then working on the let's say solutioning side on virtual prototyping to spatial mapping to digital twin based visualizations. That's again the integral part. But the major aspect, which exactly would be for AI in the coming years, would be generative physical AI. So let us understand what is basically generative physical AI, how it gets evolved, what are the major aspects of it, and how it is different from purely from a physical AI perspective. So today we are sitting at the era of AI, and if I talk about the major component these days, apart from the generative AI agents, it is more on physical AI versus generative physical AI framework. And for the audience, it is like you definitely have the chat box over there so that you can put your queries over there. And if you want to give a feedback or a query, you can definitely put that as well. So let me begin with the very first introduction aspect of how a physical AI is actually differentiating itself from a generative physical AI, and which is a kind of a modern evolution platform. So the era of, if you see, physical AI and generative physical AI, I'll call it GPI now henceforth. So this is basically a kind of a transforming automation from the performing of the repetitive task or monotonous task, which is enabling adaptive, intelligent interactions and the real world. So there are three things which exactly we see here. It is first of all adaptive. It learns from the environment. It is also based on intelligent interaction, means it has better accuracies with respect to the previous model workarounds. And third, it is real world. Real world means it's not going to be a virtual platform. It would be something in a physical platform you can see. So the transformation collaborative bots. You'll also see that there are certain innovations at my family at Compunnel, that is in partnership with Microsoft and Nvidia, where we talk about rovers, which are going to design, which are basically designing the future in terms of having operational efficiencies across various sectors, including agriculture, retail, transport, manufacturing, and smart cities as well. So this would be the societal impacts which we can think of. And definitely, if anybody has any suggestion over there, that to them what exactly is societal impact, how exactly it can be adding value to the society for good, you can definitely put that, and I'll help you out to understand how generative physical AI would be utilized in that domain, be it education or be it a mining or any other industry if you talk about, right? So physical AI as of now, audience, you know that basically it is focusing more on enabling the systems to interact with and manipulate their immediate environments through direct mechanical means. It means that the very first thing which I need to have is a physical device or a physical platform or a hardware system in place. And second, it is basically interacting with mechanical aspects. So this mechanical aspect, how exactly it can be governed by autonomous framework. So it requires some kind of intelligence. Where that intelligence is coming from is generative physical AI. So nothing else. It's all same physical AI, but powered by generative AI aspect, because now it has got a brain. If you talk about the major five sensors of, let's say, any AI system, so for eyes it's computer vision, right? We have sensors to work on smell, taste, touch, and whatnot, right? When it comes to language, when it comes to tongue, it's all about we are leveraging over there voice to text mechanisms, right? So this is kind of the similar workaround which you are doing. I'm not talking about human 2.0 or humanoids. I'm first of all giving you a crutch that where exactly, how exactly the generative physical AI is bringing control over these kind of senses. So the analogy is that, number one, we need to think of a system which can do a kind of a work which is basically at par with humans, and can work out as a subordinate to a human. Will never ever try to superimpose humans, right? That should not be the scenario here, because we can leverage it to any number of aspects. So always talking about good worldwide. So number one, I again repeat that if I'm talking about a generative physical AI system, it is acting like a brain to the sensors which are already there. So I need a brain. That means intelligence layer. The intelligence is coming from understanding the context and taking a decision on the top of it. So everybody has seen how large language models are being trained today, right? So deep learning, machine learning, large language models, these are all coming up with a kind of a decision making engine. When it comes to the sensors would be taken care by the sensors which are already available, and basis that there would be movement also. So movement is nothing else but mobility to the particular agent. So that's what I'm going to discuss: how I can make it mobile, how it can control the senses, and how I can record those outcomes, or the inputs from the senses. And then you have to use this kind of physical AI based platform, so let's say agents, in the real time scenario of farming, of manufacturing, of let's say mining, wherever you find that it is very difficult for humans to interact with. So on the Azure side of it and Microsoft Research side of it, you can see that the entire ecosystem is very well drafted, and the researchers have identified that, hey, the emerging agent AI paradigm for multimodal and cross reality, artificial general intelligence, these kind of applications, infrastructure, data, and conceptual components are mandatory. So let me explain you what exactly this system is. This system is talking about what types of different agent paradigms are available today. So as of now, I'm talking about a physical agent in place, right? I'm talking about interaction with real world, physical world in place. It also cannot be denied that we can simulate before entering into physical world. So virtual world would be the another concern. It also is to be considered that how exactly agents can interact with each other. So this agent paradigm, I'll be showcasing with a small demonstration that how can I work in a multi-agent system, how one agent would be interacting with other agent using AutoGen kind of capabilities which Microsoft has, and then embedding that particular thing for embodiment as well. So embodiment is actually making the things into reality, and that is more on autonomous vehicle manufacturing, embodied systems, etc. And then the product side of it is including gaming, co-pilots, AI for health, and then obviously it's all about infrastructure setup as well. So now if I talk about, just have a sneak peek into this particular the infrastructural requirement. I'm sure that now everybody got reasoning, everybody got a clue that how they are overlapping with each other, how they are intersecting with their boundaries altogether in terms of their capabilities, from the application perspective to infrastructure, data, and theoretical aspect. So since we have limited time period, I cannot express every aspect of it. So I'll take one particular physical world example, and then we'll showcase how it is achievable now with respect to the platforms which are available at Microsoft, right? So let me start with a concept. So the concept is physics. So no, you know that there are multiple aspects which we need to work out in physics, right? Especially on the mobility part, on the work done part, right? So that kind of agent which can attain a particular task in physical world requires the scientific aspects from physics. So the conceptual frameworks when it comes to a physical world scenario would be majorly focused by, and let's say majorly powered by, the concepts of physics. When it comes to the data, you need to have physical experiments. So you need a kind of a bot or a rover which exactly deal with humans with respect to their kind of at the level of subordinate level or at the level of being a companion level, right? So therein you are seeing most of the humanoid aspects are covering up physical aspects, right? If I talk about infrastructure requirements, we need to give the senses to this particular agent. It should be able to see, touch, uh, feel, and whatnot. It should be able to take a decision and should move across the globe, right? So if you are creating a plan, the rover on a planet, right? How exactly it will be interacting? It can go to farmlands. It can go to, let's say, your very much disastrous zones wherein there would be some kind of natural calamities. It can scan and do some kind of research in volcanoes, whatnot, where exactly we have not reached. So that kind of infrastructure we need to think. And in that infrastructure, the sensors would be what? The sensor units, powered by networking scenarios, powered by, let's say, microphones, IoT devices, multimodality aspects, right? And lastly, the application, how the application should look like in the physical world. So there could be service robots, ambient intelligence, intuitive AI, that's all working over there in the application perspective. So this is what exactly we talk about, when it comes to a physical world based rover framework or an agent framework. And as I mentioned, that there are multiple aspects to it: virtual world, agent paradigm, embodiment, product. Multiple aspects are there. So we'll cover up maybe some more next time so that we can give the entire crux. Now we need to understand, if I'm having this kind of infrastructure, what kind of a backend is required, what kind of programming is required, what kind of algorithms are required to take those kind of actions. And above all, what I mentioned is, for these kind of sensors we need a brain. So the brain is provided by GenAI layer to it. Generative physical AI is a complete solutioning from intelligence perspective to physical perspective in terms of motions, emotions, senses. That's how exactly it is embodiment as well. So humanoid. or let's say human 2.0 is basically what is going to pick up. So let us see that it's again a kind of a layer of algorithmic environment. Those my friends who are exactly working on reinforcement learning side on let's say advanced algorithms, they are already aware that how exactly we work on training these kind of agents, right? So what we have is we have an environment. So if I send my rover to a farmland, it will see the environment. It means that its tires will have sensors which can scan the soil, can check the soil health, right? It's basically arms would be able to take a piece of that particular tissue of a plant. Its vision, basically the camera would be scanning the plant leaf and will identify what disease it has, what kind of pesticides are required, or how exactly it requires a kind of a real shift. So those kind of things are taken. But now who is interacting? The agent is interacting with a gen AI layer. It means that it will be sending me the message so that I can take a call directly. So it has an environment in place. It has got, on the base of environment, it will perceive something, it will communicate, it will get learning on the basis of the simulation which I create. So simulation is very important here. And today I'm going to teach you that how exactly we can simulate in real life scenario when we are building up these kind of agents in physical world. So that simulation platform we are going to do, we are going to work out. And when it comes to memory part, we need to understand that what knowledge, what logic, what reasoning is to be given, and that particular feedback is given back to the the kind of a controller. The control is again thinking, having consciousness, having sensing, empathy, and overall cognitive system. And beyond this kind of infrastructure, right, beyond this infrastructure, we also need one more conscious layer, so that it cannot be leveraged by wrongdoers in the society. Rather, they should use it for right things in the society. And that's where exactly the concept comes from, the governance angle also. So I'll also show you that how exactly the governance gaps should be removed, so that we can control these kind of agents smartly and with government protocols, with citizens protocols and everything, right? So there are so many things to do. Let's go ahead further. I'll come back to the Microsoft researchers. Let me show you rather. So in agent paradigm, if you talk about Microsoft researchers, you'll find that there are n number of aspects which are already being covered up. So please go and log in there, identify how exactly we can work out on agents towards towards a holistic intelligence capability, how we can work out on foundation models from the agent perspective on robots, gaming, healthcare, how we can work out on the multi-agent scenarios for leveraging the large language models for gaming, navigation agents. I mean, navigation is very important. I said that mobility is very much important here to send these rovers to different places, right? So how it will happen. And likewise, GPT-4, let's say virtual agents for robotics. So that I'll be demonstrating also, how I can make the ecosystem ready for having the interactions between agent to agent, right? So let me come back to my presentation, and these were the researchers which are being carried over. But a small video is there, from NVIDIA, that shows about how exactly the real world scenario would be now set up in near future, and how we can do it right away from today with Microsoft and NVIDIA.
The era of robotics has arrived. One day, everything that moves will be autonomous. Researchers and companies around the world are developing robots powered by physical AI. Physical AIs are models that can understand instructions and autonomously perform complex tasks in the real world. Multimodal LLMs are breakthroughs that enable robots to learn, perceive, and understand the world around them, and plan how they'll act. And from human demonstrations, robots can now learn the skills required to interact with the world using gross and fine motor skills. One of the integral technologies for advancing robotics is reinforcement learning. Just as LLMs need RLHF, or reinforcement learning from human feedback, to learn particular skills, generative physical AI can learn skills using reinforcement learning from physics feedback in a simulated world. These simulation environments are where robots learn to make decisions by performing actions in a virtual world that obeys the laws of physics. In these robot gyms, a robot can learn to perform complex and dynamic tasks safely and quickly, refining their skills through millions of acts of trial and error. We built NVIDIA Omniverse as the operating system where physical AIs can be created. Omniverse is a development platform for virtual world simulation, combining real-time, physically based rendering, physics simulation, and generative AI technologies. In Omniverse, robots can learn how to be robots. They learn how to autonomously manipulate objects with precision, such as grasping and handling objects, or navigate environments autonomously, finding optimal paths while avoiding obstacles and hazards. Learning in Omniverse minimizes the sim to real gap and maximizes the transfer of learned behavior. Building robots with generative physical AI requires 3 computers: NVIDIA AI supercomputers to train the models, NVIDIA Jetson Orin, and next generation Jetson Thor robotics supercomputer to run the models, and NVIDIA Omniverse, where robots can learn and refine their skills in simulated worlds. We build the platforms, acceleration libraries, and AI models needed by developers and companies, and allow them to use any or all of the stacks that suit them best. The next wave of AI is here. Robotics, powered by physical AI, will revolutionize industries.
So, my friends, I think you have seen that how exactly we are working on the scenarios wherein the physical AI is at at the showcase. Number one, if you see, the very first thing which we need to begin is understand how these particular simulations can be done. Number two, what kind of reinforcement learning algorithms we need to devise so that we can simulate in a better way. Number three, we need to understand that how human AI experience is added to give a right feedback, and this particular systems get evolved with better accuracies over a period of time in identifying the pathways, in identifying what kind of mistakes the bots, let's say the rovers or let's say robots, undertake, and then basically including all those kind of feedback and then correcting by themselves. Right? This is what exactly we work out over there. In tandem to understanding these particular things, there are some more research works which have been done jointly by Microsoft academic researchers, and then if I talk about the NVIDIA players, and they have identified that if I'm going to have generative physical AI layer over there in terms of AI engines, what all ingredients are required. So number one, if you see, there could be certain human demonstration videos which can be serving as a kind of input for, let's say, large language models, and basis that we can assign the task. It could be symbolic task plan. So the task plan would be for a robot could be move a hand, grab a juice jar. It could be pick up, move a hand again, put it back, release, move a hand. So these kind of a logics we need to set up using large language model layer. Once this is done, there is a spatio-temporal grounding, which is more a simulation-based workaround, wherein you can see that there would be some kind of a lab area or a object area where the robots would be understanding with computer vision that where is the object, will pick up you because of the kind of let's say here motor neurons are nothing else but the kind of the electric circuits which we create, and they have some kind of the understanding on to what level I need to take it and at what distance I need to cover up this distance and I need to drop it back. So there is a affordance extraction, and then basically that's a kind of a embodiment to whatever is being planned, and it gets that particular thing. So it is not collaborative arm, it is collaborative bot. It's more of a rover kind of framework which exactly comes into mind with these kind of innovations. There are reinforcement learning based model matching frameworks which work on self supervised limitation learning as well. So these are very important research works. I'll very quickly play this so that you can understand that how turning light and walk up to the stairs, these kind of objects are being trained within the environment, right? Basically, when it comes to the let's say the simulation environments, you need to have that particular platform where you can get these agents trained on a regular basis. So it gets the best path using algorithm. The target is set by humans, and the agent goes there autonomously. But what is the major layer is decision making. The decision making is basically what, that whether I should go in a safe zone, whether I should come back, with a kind of a task which is being provided. And basically, I will be deriving those results or outcomes which are being suggested, and I give the same information by taking certain decisions back to the human user. So likewise, you can think of, and it could be that one agent would be talking to other agent, right, and they take a decision. So that those kind of mechanisms we are already building all together, and there are some other aspects. Now comes what exactly are the current gaps in the system, right? The major gaps, if you talk about, they're around technological limitations. So model accuracies, computational powers, integration with physical systems. This is what exactly comes to our mind that, hey, this could be the number one aspect when exactly there is a particular issue with the bots or rovers or let's say agents. Then would be the data issues that data quality sometimes is not up to the mark. Whatever the sensor we are using, they are not up to the mark. So the information also they carry, it's like garbage in, garbage out kind of a thing. So we need to identify very closely that, hey, what are the opportunities with what kind of vendors when it comes to picking up those right sensors, those right components of my, let's say it could be autonomous vehicle or it could be a robot in place. And obviously, yes, what kind of capabilities are required in terms of processing this cumbersome of data. We are also working parallelly on quantum side, so we understand that, hey, this is going to be fastly computed with quantum algorithms, but there also security is the another concern. So privacy and security would be the next level of game changers. Ethical and social considerations are always there. So I mean, the entire objective behind using these systems should be on a societal front. So therefore, the biasness and fairness, transparency, impact on employments, and all these things need to be worked out right properly. Regulatory standards to be met. So we need to follow, all those guidelines and principles which are set by the local level and global level authorities for the kind of use cases we are going to build up. Now let's talk about technology. What technology is required? I'll give you some kind of demonstration on multi-agent system also very quickly. So that's very important for us to understand. On the technology front, as I mentioned, that NVIDIA Omniverse is first on Azure for these kind of simulation workarounds, right? So as I mentioned that we can have AI avatars over there. Recently, in my latest use cases, we are seeing that they are very much useful for the to interact with each other, so that we can virtually feel them, right? 3D pipelines are being created. We need to work on virtual environments, so therefore, mixed reality, augmented realities are also joining hands together when these kind of initiatives are being thought for. App development would be there because we need to have a framework where orchestration is to be done and the output should be showcased to the global users. So that application development agenda is also there. Autonomous vehicles we need to think of to give them the mobility. Industrial digitalization, robotics, synthetic data generation. This is very important. By the way, anybody would like to say in the chat that, hey, how exactly they are either using it or they would love to use it, I'll definitely right away mention those answers as well. If you're not able to visualize, if you're not able to understand that what exactly is the concept behind the scenes, I can definitely make it very specific to your use cases. Otherwise, I'll show you some of the stories behind the scenes, right? What exactly we're doing all together with Microsoft and the other platforms. So synthetic data generation is very powerful tool here, because if I go with an agent in a real world, it can do the social harms and it can get failure there. So in that case, what we need to do is we need to identify ways and means that how do I collect or simulate on the basis of augmented data. So the augmented data is basically very important, and for that also we need synthetic data generation platforms. Scientific researches are there which we need to leverage when it comes to physics and chemistry and biological understandings, right? So if you're working on a genetic technology, if you are using these kind of agents, therein it's like not exactly the microscopic workaround I'm talking about. It is the decision maker I'm talking about when it comes to healthcare. So if you talk about automated surgeries to happen in future, this could be definitely be done by these kind of agents, and that is very much with very much precision. There are facts and figures which I can give directly that how exactly autonomous surgeries are really making sense. But right now, into the timeline, I think we should focus on certain areas which exactly uh, makes more sense in terms of the given timeline. So talking about the entire aspects here, so we need all these kind of infrastructural aspects, like talking about audio to face, application streaming, batch rendering. This platform physics is basically very important for from the getting the physical concepts, or let's say the physics concepts, into the live interaction of these platforms. So there I need to work out on bringing the particular applications together, understand relationship between the siloed data which is sitting there, having the mathematical physics chemistry logics into my system, and they basically help my particular agent to undertake the decision. On what basis? On the basis of the sensors they have, and that is to be finally used by the entire user in their environment. So it could be healthcare, as I mentioned, it could be autonomous surgery environment, it could be farming, wherein the farmer can get better insight on how exactly they can have better crops and production over a period of time. This generative AI engine layer will also help them to have recommendation system in place. So if a rover goes there and simply says that this is the temperature, what to do next? So earlier this angle was not there. Now what we can do is we can get the recommendation. If temperature is this, if humidity is this much, we expect a rain. Because of this rain, this crop which is already dry can get wasted. So these are the measures you need to work out. So that kind of angle is now given with the generative physical AI kind of agents, rovers, whatever we are building up. Accelerated infrastructure, Azure machine learning, data encryption, this is all required to have the complete system in place, because all the experimentations will happen behind the scenes on simulation platform, let's say on Omniverse. But the major power of computing comes from Azure machine learning in that case. And also the data needs to be secured. So data encryption part would also be taken care of. And lastly, there is a Microsoft cybersecurity suite, which basically is helping to protect the entire ecosystems, right? We are all aware that what kind of penalties these days are when it comes to a kind of a security breach, right? So that basically is the entire platform which we need to work out. If anybody wish to work on this platform, it is already available on Azure Marketplace, and definitely we can work right now on 3D simulations and all. I'll give you a complete understanding that how exactly this platform as a service is providing the developers and enterprises a full stack cloud environment. There are open source libraries also which are available, which you can use in your experimentations, but they require huge computes. So even the cost is going to be almost similar. So currently, this platform is available on marketplace, and you can register yourselves. Obviously, the pricing is but very high, at a very high side over there. It's around $495,000 for one-time payment for 1 year. But definitely, it is basically validated by NVIDIA. Then only we can get into this particular engine. So it is to be any user who's going to get into this platform also is another condition that they should be approved by NVIDIA to use this particular platform. So there are certain use cases which exactly came to my mind, to give the entire crux how exactly the systems can be used in generative physical environment. The very first thing which you need to understand here is that even if I create an agent, how it will be interacting with each other, or how exactly the system would be orchestrated. So from that perspective, we need to understand that if I have multiple agents in place, I have, let's say, 5 farming agents, 2 manufacturing agents, 3 agents which are exactly helping me to transit. So in all total, if I have 15, 20 agents, how they will interact. So multi-agents interaction is very important here. Then you need to divide your agents into 2 parts. Number one, are they going to be cooperative engagement with the agents, or is there going to be a adversarial interaction with the agent? So there are 2 ways when I can use these agents within my system in physical AI framework. Number one, how they cooperate with each other. Second, how they learn from the adaptive environments, right? It is adversarial interactions. So let me give an example of cooperative engagement. So it's basically what? You can see that they cooperate with each other. So I can designate the agents as a manager, designer, engineer, or a tester. So multiple designations are given. I simulate them. You have to complete this task. You have to write a program for me. You have to build a complete application for me. This application would be for automation of your project management tool or a platform. So every manager, designer, engineer, tester would be having those particular tasks which they can pick up, and they will do the task automatically in an ordered fashion, right? So there's a kind of a designated environment. And disordered is what? I can assign my task and let the agent understand who's going to pick up that. So it's more voluntarily done over there. So it's more disordered. So I don't expect that disordered should be created these days. Majorly, if it's an ordered agent which is cooperating, which are cooperative to each other, would make more sense when it comes to the interactions of these agents. So in cooperative multi-agent system, the agents are actively collaborated by assessing each other's needs, and they're sharing the information. And disordered cooperation allows free expression but lacks organization. So that we should avoid. But that can be done parallelly, right? Why exactly I want to create a disordered let's say engagement with my agents? Could be that I'm not clear. If I'm not clear, then definitely I would simply randomly, create these agents. Or maybe I have monotonous tasks. So a monotonous task doesn't require that this would be the designation of agent 1, 2, 3. Rather, you distribute that randomly to them. So that's also a kind of a use case where it fits in when it comes to a disordered engagement. On the additional side to it, that is adversarial, which is more of a gaming kind of environment, you can think that it's inspired by game theory. So this multi-agent system is leading to a robust behavior. The successful applications include debate and argumentation, improving response quality and decision making. So here you can see that, hey, you're uh, giving these agents into a particular, you're dragging these agents to a kind of a simulation environment. One basically is a lawyer, one basically could be a judge, and one basically could be the culprit, who is basically a kind of a criminal. And then you can think that how exactly they will interact. So you need to learn from that system. So these kind of adversarial interaction also can help you to learn from mistakes, right? So that's why these kind of systems also would be existing in coming days. So evolution of agents, if I talk about Gen AI or physical AI, because in our language, in artificial intelligence, everything which is can be, which is able to perform autonomous tasks, basically is identified as an agent, and therefore AI agents could be generative AI agent, it could be physical agent, it could be generative physical AI agent, blah blah blah. It is only depending on to what level of automation they carry. How do we identify? So the very first layer is human directed AI, which acts under human direction and approval. No independent decision making or power is there. Executes the predefined tasks as instructed. There is a second layer to it, which is agentic AI, which is acting on behalf of a specific entity, exhibits a goal directed behavior. It makes a certain decisions within defined parameters. It means that when it is a human directed, it is more having human AI experience. When it's agentic, it is basically a kind of a partially autonomous agent, which makes decisions but doesn't, I mean, which identifies the decision, which recommends but doesn't take the decisions by itself. In autonomous, you get the 100% autonomy, wherein not only identifies the measures, it also it doesn't get the it doesn't get it validated by a human. Rather, it automatically takes those decisions, execute the task autonomously. So that's how exactly agents are being evolved. And when I talk about generative physical AI agents, they are more from autonomous AI perspective, level 3. Now let's see what kind of societal implications we can have when we are working with these kind of agents, right? So we had been working with a number of aspects from agriculture, retail, transport, and manufacturing domain. We have identified certain use cases on leveraging these generative physical AI, agents. But before I showcase the applications, let's understand what exactly is an innovation I'm talking about. Then I'll come back to the that, hey, what this particular rover can do. So we have named it VRE for the time being. It's a innovation from our side in identifying that how exactly a rover can be devised in such a way that it has got all the sensors and controlled by a generative AI layer, or let's say agent based mechanisms. So that's the framework which we have identified. Now this is a rover, so it can identify and resolve certain problems on agriculture, retail, transport, manufacturing, education, health, whatnot. Now you can understand that this rover, if it is there, we have already been working on a kind of a simulated environment to get these particular things updated. So in that particular aspect, you can see that these kind of rovers are addressing critical issues like inefficiencies, high operational costs which are involved, need for real-time adaptability in different industries where there could be a societal impact as well, right? Where exactly the human outreach is very dangerous or very hazardous. We can definitely ask this rover to take the decisions, go there and identify that what is the environment, communicate also the same, right? It's not taking snapshots. It's not taking, let's say, the detail on the sensors. It is also communicating that after having this kind of vision, or let's say sensor data collection from this area, I tell you that it's not safe, you enter in here. This is a kind of a gaseous state and blah blah blah. That kind of a thing you can think of in a mining industry. So that how exactly it is getting resolved. So these kind of problems can get resolved when you give it a platform to play with, platform to simulate. On the basis of our feedback, we can train it in a better way, and then it can achieve the kind of tasks which are being designed, and the kind of agent system which we are creating to help it to learn from the environment and then do the task. So it could be multiple agent system basically, right? So rover is basically addressing critical issues. It offers significant advantages over competing technologies, and also provide a unified solution which is dynamically and let's say significantly impacting on the operational context. The end product is basically, if you see, it is highly customizable. It can be intelligent bot, it can be intelligent rover, it can be agent which exactly takes a decision. And if I think of certain aspects in precision farming, how exactly we can leverage these agents, so we can work on a optimized resource usage base, enhanced yield basis, emission detection, working out on, let's say, requirement of water for the plants, identifying what kind of pests are there, identifying that what kind of disease this plant is carrying, and then taking the right decisions also at the same time, ordering the medicines to spraying them, and whatnot. Then this can get converted to a drone framework, and then that scans the environment. Then it goes to a satellite based workaround where it scans the geographical boundaries, identifying what is the NDVI rate here of the infrared versus red light aspect, and then how I can identify this vegetation requires immediate attention because it's degrading its soil quality. So these kind of things you need to understand, that which we can leverage definitely from the agent perspective. And what exactly the solution at this juncture would require is that we need to have AI and machine learning models for sure, especially reinforcement learning. IoT sensors, camera, GPS systems are requirement number two. We need to have high performance servers or cloud based platforms. Quantum technologies can be leveraged here in terms of processing units. User interface is required, right? So that we can have intuitive applications for interacting with the rover, boat, agent, whosoever is there, the farmers, right? Communication modules are required for Wi-Fi based workarounds. The Bluetooth is required. The cellular networks are required for real-time data transmissions, right? We also need the layers of actuators and robotics components, right? All these particular dynamic environments or components are required to build up this entire solution, and that requires the conscious efforts in terms of investing. So that therein, this could be the next level of AI revolutions. So I'm not talking too much on this side. Rather, let me help you out with how exactly these agents, if they are multiple, how they interact. So as of now, you can see that if I create multiple agents, one is on a farming note. If I say I created a resource allocation agent, I create a waste reduction agent, I create a security agent to secure my application, and there is a user proxy agent which I've created which acts like a main boss. So how the ecosystem looks like, how exactly these agents would be playing in the market, right, or in the farmlands. So they have to consider the machine learning systems, right? For example, if I take a very simple use case, I want to predict the, let's say, the disease of a particular plant. So what I do is I take images. These images are basically of plants. I have machine learning layer over there which has got some reference images, or which is a pre-built model which already have diseases images. So it tries, the CNN algorithms, what they do is they try to map each other and identify that if it is rightly classified or not. Out of 100 diseases, which diseases this plant is having, best match is identified. So that information is coming out of the machine learning system. It is given back to the major agent, and who is interacting there. This could be a health agent which is scanning the plant and then sending the information. This information is basically stored over there with the major agent. Now this major agent is scanning all the multiple agents, and now we can think that how exactly they will play different roles altogether. It could be a company, it could be manufacturing unit, it could be a farming, it could be a healthcare unit, wherever you want to have this kind of autonomous engines, right? So they can extract data from real-time scenarios coming from different hybrid clouds, and we basically take the information, and then on the basis of our triggers, we generate the outcomes. The knowledge base for this agent, which is powered by large language model layers, Azure OpenAI is the best in class example here. So it can understand from these agents and can take the record of what should be now the action. It recommends not only these agents, but also it can recommend the humans, or let's say via these cloud platforms again, which is having web applications on the go. So there's a kind of a large language model agent framework and orchestration. Crew AI, line chains, Microsoft AutoGen, they play vital role there. And since I have discussed now on AutoGen, let me give a very small use case here, that how exactly AutoGen can be leveraged in multi-agent scenarios. This could be agent which are in physical form, virtual form, whatever. As I mentioned that agents can take embodiments, they can be autonomous, they can be virtual, they can be real, whatever the kind of thing is, right? So since I mentioned that we can have this kind of agent system, what all things, use cases, are available within the open source framework at AutoGen within Microsoft Research Work. So if you go to Microsoft Research Platform, you see AutoGen over there. which is helping us to build multi agents, and that too with GenAI applications. Let's say we do a small check here that what kind of diverse applications right now it supports. So you can think of a student assistant kind of an environment where there is a academic faculty over there, a student is there. Between the student and the faculty, there are assistants helping academician to understand the performance of a student and helping student to improve its performance basis the learning given by expert or the academician. So likewise, you can see that this could be a J agent which is associated with the student. There is an agent which is associated with the expert, and they both are interacting with each other. So this agent says on the behalf of student, this agent says on the behalf of an expert, and they interact. How do we simulate? That is the major thing. I'll show you one scenario. Then there is a retrieval augmented chat, which you can think of. This could be, again, don't get carried away. It could be on a generative physical AI also, right? So I'm saying that again, that virtual versus physical, there is a very thin line of a difference. That if you give it a kind of a hardware unit, and the same task is being done over there with sensors of 5 sensors along with GenAI, it becomes generative physical AI. But the major brain is coming and the logic is coming from the large language models. So the decision making could be there. There could be multiple agent coding, which can be between a writer and a safeguarding tool. It can be basically on a dynamic group chat. It could be conversational chess game kind of a agent wherein both can converse and then can play the games, right? So what do I do there? So right now I've just waited my keys to be leveraged here, and running this, I think we have got around 500,000 kind of tokens which were utilized. So you can configure here. You can use the installation of, you can have the installation of Autogen. You can configure these model aspects. You can provide your API keys, base URL where you are running this, and then obviously the API type version are available for you to work on Autogen. If I go ahead further, okay, so if I go ahead further, you can see that this is how exactly I can set the user proxy agent, which is the major admin agent, right? So this would be the centralized authority, as I mentioned in my diagram also, that this would be the proxy agent, which is the main boss, gets the execution here. That hey, you're a human admin, interact with the planner to discuss the plan. Plan execution needs to be approved by this admin. Okay. Then next, what is the context here? So I want to create a agent system, multi-agent system, which are having engineers. Okay, you can see engineers, the controller, the proxy agent, which is a admin. There is a planner and the executor. There is a critic as well. So there are more than 2 agents. You can see there are 4 to 5 agents which we have created. So engineer is basically is given a task. You follow an approved plan. You write Python shell code to solve the task. Wrap the code in a code block that specifies. Don't include multiple code blocks in one response. Do not ask others to copy and paste the results. Check the execution results returned by the execution, right? So you can program it with respect to the prompt for the second layer of agent, that is engineer. You'll find everything on AutoGen platform within Microsoft Research. So please do that. Complete all those kind of exercises before you could do that in real time, right? Then you can create a scientific agent. The scientist is basically nothing else but he's advised to follow a approved plan, able to categorize papers, research papers. We have to identify research papers on the from online resources, and after the abstracts are read, it needs to categorize those papers, right? You don't write these research papers, by the way. Then there would be a planner. Planner is again suggesting the plan, revise the plan based feedback from admin and critic until the admin approval is there. The plan may involve engineer who can write a code, scientist who doesn't write a code, explain the plan first, be clear whether this step is performed by engineer or not. Like that, you can see that you can give the instructions to multiple agents within this ecosystem of agent device framework or configurations, right? Then there would be executor. Then executor code can be written in Python program, and with respect to these kind of functionalities, you can give a human input mode. You can give the code execution configurations. Last, how many messages to read, to refer, what kind of working directories to be followed, like what kind of categories of papers, or it could be Docker, it can be utilized or not. So all these things you can set up, right? Then you talk about a critic. Critic is also is basically is available now to check the plan created by a planner. It claims it basically it also claims that is all perfect. It quote from other agents and provide the feedback as well, and check whether the plan includes adding verifiable aspects or not. So this is how exactly you can create multiple agents and then create an engine of group chat. Group chat is basically a functionality within AutoGen, and there you can assign all these agents, user proxy to critic. All the agents can be wrapped here, and messages can be in the form of a list. Maximum rounds you can provide is around let's say 50, that you can customize. There is a manager now. This manager is basically a group chat manager. Otherwise, how exactly it will take a control? So that would be done. Now, please consider that is again a virtual example. But in real time, what will happen is I create a IoT agent number one, IoT agent number two, computer vision agent number one, computer vision agent number two. Like that, all the sensors which I mentioned, they need to be trained here. And basis that, they need to interact with each other. This is an interaction platform. But for real time practice, movement and all, right, pathways, you need what? Apart from AutoGen, you need these things to work out. Wherein you need these environments to work out, right? So be very clear that whether I need to work in a physical environment, what kind of agent training should be there. So I can instruct, hey, you go to that room, check out algorithm score, what kind of penalty is given, reward is given, take a left, take a right. Now you can think in that way. I hope everybody is enjoying this, right? And they can understand that what I'm referring to when I talk about how the virtual environment can be created within the physical environment, right? Similarly, so simulation is the first thing and the game changer. Here also I'm simulating, right? If you see. So if you go ahead further now, what we can do is we can then start on initialization of this chat. And what I do is I create a particular, functionality dot initiate underscore chat function, which works on the manager, which works on the message that find papers on large language model application. From where? From Arxiv in last week. Create a markdown table of different domains. It's an advice, sorry, it's a what I should say command given to this agent. Next, what will happen then? Once you run this, then admin basically is saying here to chat manager, it is being displayed. Find papers on LLM applications once you run it. Next speaker is planner. Planner is picking up the task, right? He plans the thing. Step one, two, three. These are the detailed steps. Engineer, scientist, engineer. What you need to do. These are again part of the plan, correct? I'm sorry. So the agents were created. Now agents are interacting. Next speaker is here, automatically coming in, critic, because there is a chat manager to control them, right? Feedback on additional requirements we need. This is missing, right? Again goes back to the main agent. Again admin comes in. Then it says provide a feedback to chat manager. Press enter, skip, use auto reply, or exit. It's all happening automatically, guys. And then comes the code. Then executor will come, right? So engineer is there to write the code. So let's get started with step number one. Collect the papers from this link. He creates a script, create the function automatically. Next speaker is basically an engineer now. Again, to the chat manager. Once it is done, there is something basically the module is not installed. Okay. So it then gets the confirmation, right? To do that. These kind of nitty-gritties could be there. So then the engineer starts working again. Then as I mentioned, next speaker is this executor here. Executor will execute the function of the code, which exactly is being prepared by the previous user or let's say agent. And then you can see that executor is now executing code block 0, doing the installations. And as of now, you can see that successfully installed all the libraries. Now the titles of papers are also identified. These are URLs of those particular papers which are being assigned to this agent to work upon. Dumping all these papers, blah blah blah, and number of papers it has downloaded. I think it was 150 or 50, correct? So those papers get downloaded. I mean, the URLs are being fetched, and then the scientist comes in here. If you remember, scientist was asked to categorize these papers once they are actually listed. So then says that standard set of domains for classification are these papers, right? These are coming from these categories. All right, guys. Step 2 is basically again filtering the papers by domains. So I'll review the abstracts and categorize each paper. Here the categorical list does that. So just think of a drug discovery team who are working on research papers, pharmacovigilance, these kind of use cases. And these agents are the similar agents which I have just created. So they will definitely work out. They will identify which papers are helping us to identify a better do the drug discovery process, clinical trial mechanisms. Pharmacovigilance will a team agent will understand in which papers it is mentioned that this molecule is not useful for the society, for humans, I mean for patients. How many reports are there in terms of adversarial drug reactions? So you'll find that those kind of aspects, right? Can be They will be leveraging these paper downloads. Then comes the engineer agent, and he says that here's the continuation complete markdown table after categorizing the papers as well, isn't it? And then if you go ahead further, you can see that there is a critic, and this critic is basically again chatting with the manager. Here's the complete markdown of table of categorized papers along with the publication dates and archive URLs. Fabulous work, Autogen. I think it's working best in class, with respect to the framework here. And does that work around? Next speaker is again the admin, right? Then the scientist is being called upon here. Scientist discussing with the chat manager. Here's the complete finalized markdown table of categorized papers again. And like that, it goes on to multiple users, agents again and again and again. And let's see where it gets stopped, right? So this task is autonomously being worked out whenever there is critic is identifying some mistakes, redoing that workaround autonomously, and sending back the information. And lastly, these are being the caches which are available now for the papers, and these agents are basically helping you to create or let's say download these papers from the given URLs, right? From the multitasking perspective. So this is how exactly what we do over there. Any question, guys? Now coming back to the presentation, if there is no such questions, right? So if you go there, now let's think of these use cases in detail, right? As I mentioned, these agents could be interacting within a multi or agent system environments. They can do well in terms of agriculture, they can do well in retail, they can do well in transport, they can do well in manufacturing. What are the use cases? As I mentioned, mostly on the agriculture side, these are the kind of rovers which goes to the field, identify the crop health, weather patterns, help the farmers to decide what kind of decision making has to be done as per the seasonality. A retailer rovers would be helping to have better inventory management. They can monitor the stock levels in real time. They can suggest and give recommendations. Going to a shelf, scanning that, and seeing that hey, this kind of demand and expecting and basis that you need to get this particular product as per the allowance which is given by your supplier at this particular stage, and that can be kind of a thing could be done. So they all need knowledge bases. Knowledge base is what the data which we need to fetch in. Otherwise, they are all set to the task. They are going to be engineered with prompts with large language models in a easy fashion. What we need some kind of experimentations like Autogen is helping us with, and in physical AI perspective, simulations require NVIDIA kind of a platform within Omniverse environment within Azure Marketplace. So these kind of things can be easily trailed. Apart from that, Microsoft is also providing you smart manufacturing platforms within Microsoft Fabric ecosystem. So those things can be also integrated here, right? So you can have automated factory rovers can, or let's say bots can monitor the health of assembly line robots and can also alert the technicians to perform maintenance and all. Right? So with that, I think we have discussed so many things. There are multiple aspects also, like we can work on water management, data analytics, and resource optimizations within generative physical AI powered rover frameworks, where you can collect the data, process the data on the similar kind of agent node, and the agents would be working on IoT sensor side, SCADA sides, collect the information, do the automation of the workarounds. Codes are also written automatically if you see with my engineer, right? So that engineer is writing the code, one is executing the code, one is basically uh, uh, downloading the data, dumping it, chatting with you, whatnot. So how do we train them? So it's basically on the aspect of human feedback. As you see that from the NVIDIA video also, that generative physical AI basically requires what? The active involvement of humans in reinforcement learning based human feedback systems, RLHF, right, on your custom data. So that needs to be addressed here. So that will help you to have correction of the errors. If anybody need any support on how do we work on reinforcement learning again, I can definitely discuss that, and you can just let me know. Otherwise, I think if those are already understanding reinforcement learning the best possible way, they understand the reward penalty mechanism would be helping us to devise the policy in a better way, and we can definitely tune the performance of these agents over a period of time. If I use a kind of infrastructure as a code maintenance platform for this, so we can definitely think of an ecosystem where I can integrate with every cloud-based system along with the Azure Marketplace based platform. I can have infrastructure as a code to have everything getting created over there, to having a best-in-class CI/CD pipelines for machine learning operations as well, large language model operations as well. And if you think of that, it could be let's say multi-agent framework which we can work upon. These are all like our possible engagements which we are globally working with Microsoft platforms. The future ahead is basically on a human-centered AI experience with generative physical AI. Therein, what we need is we need to follow 18 principles of, human AI experience. So those 18 principles, I'll share the list right away. So definitely you need to take care of, and we call it HX toolkit actually. So we'll get it from Microsoft. So this we need to work out for creating any AI agent, for creating any AI application. You need to follow these guidelines. Not only from Microsoft, from NIST, if you find there are best-in-class frameworks available. So when you decide to bring any agent in place, what you need to do, you need to follow these two guidelines. Make clear the way the system would be working. Make clear how well the system can do what it can do. During interaction, there was basically four different tickets you can see, guidelines which you can see we need to work out. When the AI agent goes wrong, what we need to do over a period of time, what support is required for these, we need to follow these guidelines. So when AI agent basically goes wrong on, let's say, support efficient invocation, or let's say if I talk about during interaction also with the systems, if it goes wrong, what we need to do, let's say I want to remove social biases, we need to work out on societal impacts, right? So if I click that, you'll find that again now we have these particular aspects to cover up, right, within these ecosystems. So if I go there, you'll find a way out how exactly we can ensure that AI systems language and behaviors don't reinforce undesirable and unfair stereotypes and biases. So these kind of checks we need to work out, and there are certain examples which you can use. You can have platforms also, like Fairlearn is a platform which Microsoft is also leveraging in the dashboarding. So there you can see that they can be further monitored. So keeping it short, you can see that we are having uh, these particular systems in place, which helps you to work out on governance side also in the best possible way. And I can't see my. Okay, I'm sorry for that, but yeah, let me come back to the closure of the session and then let me know how was the session as well. So what exactly you can now think of in the future is we'll be having autonomous construction based agents, smart manufacturing, personalized robotics, advanced prosthetics and implants could be there, eco-friendly material innovations would be there from the different ecosystems in societies. Smart cities need these kind of agents to have better checks in terms of the local authorities, local bodies, the water system, drainage system, traffic management. All these things need to leverage these kind of agents, right? So, with that, I would like to thank the entire team Microsoft Reactor and the community as well, the audience who were silent listeners today. I couldn't see if there are certain chats. Back to you, Rashmika, and would definitely like to hear from you now.
Thank you so much, Dr. Ravi. I think people were just listening to you at the moment and we don't have any questions. However, folks, I have shared the social handle of the speaker. So, in case if you have any questions later, please feel free to reach out. Um, but yes, I think we just had one question. Uh, Let me just that bring for you.
Question.
Yeah, it's up there on the screen. Can you see?
Hmm. Not in the chat. Is it on the screen?
Yeah, it's on the screen.
Let me refresh. Mm, not yet. Do you
So
have the question in
basically,
your
yeah, so basically, IoT with DB wants to know, uh, probably to understand how we can ensure that AI, whether in software or physical form, like humanoids, I don't know if I'm pronouncing it right, is
hand?
used for safe purposes. Whether we think it's humanoid AI, we often picture types Typsocian sci-fi.
All right, so I got it. Like for example, we are being asked that how exactly we ensure that how we can make this particular systems. Not only make the systems, but this is basically for something good or not. So that actually goes in the hands of the governance mechanisms. From the individual contributors, we can definitely check from our side. But when it comes to a global authorities, definitely, let's say European Union comes on its own AI policy frameworks. Next, regulates from the security perspectives. United Nations, they go on everything. So in that case, I would say that hey, we need to have sound mechanisms from ITU to United Nations, from WHO, from let's say the eminent authorities coming in from United Nations umbrella. So they would be the right players in this market to have those kind of sound systems, because they are actually going to take the lead further in detecting and penalizing the task accordingly. So on the local level, you can see that the local government plays a very important role here, and they should have those systems in place to identify whether it is really impacting in the society in a negative way or not. But from our side, if we are, let's say, developers, programmers, it's very simple to we just need to follow those guidelines which are already being publicized. We'll also share something on a governance as a service kind of a platform very shortly. I'm continuously working on that how a global ecosystem could be created, and we talk about those kind of task forces which are already there. So globally, we are working on global AI and cybersecurity task forces. Those kind of initiatives would definitely identify, curb these kind of negative practices. But yeah, moreover, if you talk about charity begins at home, so we need to say that whatever we are dealing with, it is from the goodness state we need to offer, because any solution, any technology can be leveraged in multiple ways. State of passion, which helps you to generate more ROI of it. A state of goodness where you can give back to the society. A state of ignorance when you can do the social harms. So yeah, that's very much self-explanatory, and it should be monitored by the self than any government authority comes and catch you over there.
Awesome. I think we are good. There's another one.
Mhm.
You're able to see, right? The question.
Not really. If you can dictate,
Okay.
Rashmi.
How do these system interact with unexpected obstacle when executing their task? Can that bed trend too?
Sorry, if you can come again.
How do the system interact with unexpected obstacles when executing their task? Can that bed trend too?
Okay, I though I couldn't get the real context out of it, but I think it's that if there is a particular obstacle coming in within a kind of a real time deployment of these engines, and there is an obstacle, how exactly they fine tune it, correct?
Yeah.
So obviously there is a mechanism which I mentioned. There are two things. One is on autonomous node, wherein reinforcement learning is going to help you out further for having those kind of reward penalty based mechanisms and auto tune it. Otherwise, the human based inputs would be helping the system to avoid those kind of hurdles in the next run. And when you retrain your models, to work on these engines, and they will automatically take that particular feedback into account. That's why I said in the end that RLHF frameworks powered by reinforcement learning and human feedback are really important for us. to fine tune these applications to work on monitoring and even making them better over a period of time. Yeah.
Thank you. Thank you so much for hosting the session, and thank you all for joining us today. Please visit Microsoft Reactor website for more upcoming sessions. Feel free to use the Learn module links. This will give you access to additional resources to take your learning further. Thank you all once again, and enjoy the rest of your day.
Thank you, team. Thank you, Rashmi.